All right, so in this video, we're going to talk about depth of field. Specifically, we're going to talk about what it is, how it's used, how it works in the real world, and then we'll go and set it up in Mental Ray from Maya for our own use in 3D image creation. All right, so what is depth of field? For those of you who aren't quite sure, the depth of field refers to that zone in a real camera that is in focus, where your subject matter is tack sharp. It's just that specific zone. So when we say we have a shallow depth of field, this green area would be much smaller, all right, and the objects in front of it would be out of focus, and the objects behind it would be out of focus. To have a deep depth of field, like you would see in something like landscape photography, that would mean that this green zone would extend very, very far. And that's all we're talking about. So, I mean, what is that? It's pretty much just another tool in the toolbox of that we have for image composition. It helps separate objects from the background, right? It provides detail only where we want it and removes it from places where we don't want our audience looking. Okay? It also gives the viewer and audience a place to look. You're going to be drawn to sharper lines as opposed to large diffuse colors. So it just gives us yet another way of guiding the gaze of our viewers and audience, right? For example, in an image like this, we have leading lines and perspective, and we have contrast to draw our eye. But one thing that's also helping here is the fact that our background is out of focus. Here we have a bridge, which would be a fairly visually confusing and visually cluttered background, but we're diffusing that quite a bit with the depth of field and giving us one place to look. All right, so how does this actually work in the real world? And it's important to understand this because as we use it in 3D, we want to understand the language of the depth of field, and that language is based on how it actually works. Right, so let's take a look at a very simple lens here. We have a lens body. This obviously leads to a camera, a simple lens, and an image plane, just like this. All right. So let's say we're going to take a picture of a candle. If we could pick a point anywhere on this candle, it wouldn't have to be the flame, it could be down here. No matter where we are, we're going to get a bunch of rays of reflected and created radiated light coming off of any point of this. It doesn't have to be here, but I'm just picking this point because it's convenient. It could be down here, anywhere. All right? These rays are going all over the place. Well, we're only worried about a small subset of rays while we're talking about this. It's the ones going right to the lens. Okay? And you notice that we do have a whole range of these. Even from this singular point, we have a range of rays coming from this point. Okay, so what happens is inside of a lens is that these rays get bent and twisted and, well, not really twisted, but bent and moved all the way through until they focus on the image plane, all right? And so this singular point becomes another singular point on the imaging plane. This has the side effect of flipping the image upside down, if you didn't already know that. So what happens here, where this convergence happens, is actually called the focal plane. This focal plane is the point at which the zone that we're looking at is in focus. And so we can move our focus point out here, which changes where this point moves in the back. Right? For example, if we were to change our focal plane, right? If we were to focus somewhere else out here, the rays coming from this particular spot would start to have a focal plane behind the image plane. This is what causes this the defocused image quality that we have. Okay, so and this area here. Now remember, this is a two-dimensional view of a three-dimensional thing happening here, right? So what would happen is we'd have this little circle of light that falls in this spot. We call this the circle of confusion. This little bit of this area here is what causes this sort of like radiated blur. This isn't a simple Gaussian blur. This is a very particular kind of blur. And it's due to how the light coming from here is focused in front or in behind the plane, right? See, if we move the focal plane in front, we get the same thing. We have an area as opposed to a point, right? So that has another circle of confusion there, and our image remains out of focus. All right, so, but that's not, I mean, that's how it sort of works, but there's one other additional thing, and there's, the way we're looking at it here, we have no control, right? We're focusing, but we don't have a way of controlling this. And this is important. We want to be able to control it, right? And in a real camera, we do that by using an aperture, usually an iris of some kind. Okay, so when we introduce an aperture, this is closing down the amount of area inside of a lens that allows light through. Basically what happens is we get a smaller subset of the light that can travel through, right? So instead of being able to get everything that crosses through this lens, we're only getting this smaller subset of stuff that gets focused. Okay, this has an interesting side effect. Okay, with our large aperture, and we'll call this a large aperture, we can put the focal plane here, and we have a circle of confusion about this size. That's the area that these rays can land on the image plane. If we reduce this aperture, you'll notice that without moving the focal plane, we're creating a smaller circle of confusion, right? This is the control. This is what allows us to have a shallow or a deep depth of field. It's changing this aperture. Okay, so you can see that with the same focal plane, we're getting two different circles of confusion, and we get two levels of defocus, right? We have this one and this one, okay? So you can see that the focal plane is not moving. It's just how much light we can let through, and by constricting that, we actually can increase or decrease the depth of field. Okay, so why don't we head over to Maya and we'll see how we'll set this up, and we'll talk about all the things that go along with it. Right, so let's head over there now. All right, so here's our simple scene in Maya. If you've looked at the linear light rendering video I have, you'll be fairly familiar with you. I've added an object here, just a little gyroscope for us to play with, right? So keeping things simple, the first thing we want to do, since we're talking about a tool for image composition, is we want to create our camera that we're going to look through and render from. All right, so I'm going to go ahead and create a camera. It's right there, and I'm going to go ahead and look right through it. Okay, so let me pull myself away here. So, and again, we're talking about image composition, right? So we might as well get all the tools rolling that we can. So we'll try to set up the shot. One of the things that right off the bat that I don't know is really, where is my render going to be coming from? Right, if I check my render settings, you'll notice I'm working in linear light. But if I scroll down here, I see that I've got a HD resolution, or an HD aspect ratio of 1280 by 720. And actually, while I'm here, I'm going to go ahead and set this render camera to camera 1, which is what I'm looking through. All right, so coming back to this, I know this isn't quite the right aspect ratio. And if I open up my attribute editor for the camera, now I really don't know what I'm looking through, right? So we want to solve this first, because the first thing we want to do is be able to use regular compositional sort of tools to get us to a good place, right? So in our camera attributes, we want to scroll down and find our display options. In here, we have this option here to display resolution. This will generate a box that shows us our aspect ratio of what we're going to be rendering. Now, it's hard to tell whether this box ends here at this line or continues on. So what we want to do is adjust a little bit further down the overscan. All right, so let's bump this up to, and just kind of work your way into it. 1.2, there it is. Okay, so there's what we're rendering. Well, that helps a whole lot. Okay, so first thing I'm going to do is get myself into a position where it makes a little bit more sense. Get in there. Maybe just for giggles, I'm going to just bump my focal length up a little bit to something a little bit more shallow there. Here we go. All right, something like this. Okay, so that's not bad. I mean, if I render this, this shouldn't take too long. I have my render quality set down pretty far to half size. Of course, with the screen recording, this can take quite a while. But one of the things you'll notice right away is that, with this background and the colors that I have chosen for this gyroscope, which is sort of a brass look, we are going to see some. This is going to be a little muddled over here. Even with a rim light and a nice fill light and some good reflections, we're not able to really pull this off the background as it renders away. And we'll see that soon enough as we see it. So depth of field is going to help us here with our image composition. So I'll slide this over. Not quite done yet. So I'm just going to let us finish watching it, and then any subsequent renders I'll do, I'll probably just pause the video and let it run. Okay, so overall, let's just say I'm happy with this composition. It's not really that terrible. It's not a very interesting scene to begin with, but we can work with it. All right, so we'll let this finish out, and I'm going to store this image so we can compare things a little bit later. Okay, I'll store this. There we go. Now, so the first thing that you may think about doing if you're setting up depth of field is to run over here to your camera, scroll down, and right off the bat, I mean, the second attribute that you have really after film back is depth of field. And so you might think, well, this is easy. I'll just click this and everything is great. Well, it's not really that great. Now, one thing that you'll notice is that in Viewport 2.0, that you'll get a preview of this if you have it turned on up here. And by changing your f-stop, nothing really happens here. Changing my focus distance, well, that has an effect, right? So you can kind of zero in on things. But ultimately, the problem with this particular setting is that it's going to use an algorithm that it's fairly inefficient, right? So what we want to do is use the most efficient algorithm we can in Mental Ray and give us as much control as we can. And this does very little of that. So we're going to go ahead and turn that off because it's kind of pointless for us right now. Right? So what we want to do is we want to roll down here to the Mental Ray tab. And inside this tab, we have a couple of things that we can attach to the camera. Environment shaders, volume shaders, lens shaders. And if you've ever played with the indirect lighting physical sun and sky, you'll notice that you do get environment shaders and lens shaders loaded into your cameras. That's a whole nother topic for another video. But in this case, what we want to do is introduce the best option we can for depth of field. Okay, so let's go ahead and click our render node box here, and we're going to roll down to Mental Ray lenses. And we have a couple of things in here, right? This MIA exposure photographic and exposure simple. Those you'd see with the physical sun and sky. Here's that physical sky. We have a couple of options for depth of field. We have physical lens depth of field and the Mia lens bokeh. All right, and this is what we want to use. This is my favorite. I mean, I'm sure there's people out there who would like this. Personally, I really like to use the Mia lens bokeh. So I'm going to go ahead and click that, and that gives us these options here. Now, before we go on, let's have a quick chat about what that is, right? So the Mia lens bokeh, the node looks like this. So if you're trying to find it in the hypershade, it's going to be listed under cameras, and you'll look for this node here. The easiest way to get to it is through your Mental Ray, through the Mental Ray tab on the camera. Anyways, so it's called the Mia lens bokeh. Now, what does that mean? Well, first of all, the Mia is the mental images architecture, So this is set up for the architectural rendering, and those tend to be all very, very good shaders, right? So, what is bokeh? Bokeh is the characteristic of a lens when it's out of focus, right? So it's just the phrase for what it looks like out of focus. And some lenses have a nice little circular bokeh, and some have, you can see the blades of the irises, and some have really interesting shapes like this one from a mirror lens. So that's all. That's what we mean when we say bokeh, right? And some people say bokeh, and some people say bokeh. Either way, that's what it is. All right, so back to here. So what are the settings? Well, first of all, on and off is really handy because sometimes you just want to turn it off and just do some rendering. Other times you want to render with it on. Turning it on, you are going to get a render hit. It is going to slow things down, but not nearly as much as it does if you just go through the depth of field tab in the camera settings, right? The plane here is where we are in focus, right? So back to here, all the way back, our plane is the point from the camera to a spot in space where things are in focus. In this case, it would be this point right here, the center of this in focus zone. This is our plane. So whatever that number is actually a distance from the camera where things will be in focus. This radius is actually the size of your aperture, right? So making this a larger and smaller number is the setting that gives us that control over our circle of confusion and how much depth and how much defocus we have on in our scene. Samples is something you're going to have to set up, is probably turn up in order to get rid of some noise that's going to happen in there. As your radius aperture gets larger and your things get more and more out of focus, you're going to need more and more samples, which will in turn increase rendering time. Now, you have to be careful with this because you probably don't really want to go nuts with this. This is an effect that you want to look at a lot of photography and make sure that you're not going out of control, and you want to keep it within the language of the real world. Blade count is how many blades are on the iris. This will only come into effect when you're looking at things that are very out of focus and very bright, like these lights here. Here we have a blade count of 5. 1, 2, 3, 4, 5. Right? We can also rotate those blades, and we can also load in a custom bokeh if we really want to do something like this or some other custom shapes. So that's what all the settings are. So right now we've got it attached to the camera, and it's set out at a plane of 100 and a radius of 1. Now, probably, for me, what I do right away is I automatically drop this down, because if I accidentally render with it on, I don't want to be rendering giant defocus zones. The other thing I want to do is I want to set up my plane right away. You can go ahead and render this if you want, and then try to zero in on what you're trying to focus on. But that takes a long time, and it's never quite right. So we're going to do something and make sure that we have an exact match. So let's pop back over here into perspective view, right? Find everything we're doing. Here's our camera, right? Here's our scene. And what we want to do is measure the distance from the center of our camera to the point where we want to have in focus, which is the center of our gyroscope. Now we do this using a measuring tool, right? We have this distance tool here in Maya, which is really handy for this. So the best way to do this is it gives you 2 locators. I'm just going to click once and twice, and you see I get 2 locators. And I also get this distance. Now, unfortunately, in Viewport 2.0, it's not going to list in Maya 2014. So what we're going to do here is just switch to regular viewport, and you can see that as I move these around, that number increases and decreases. It's just a simple measurement tool. So what we're going to do is I'm going to hold down the V key and middle mouse click over at my camera and just snap it right to the center of my camera. Now I have this freedom to move this around and find that spot where I want to be in focus. Once again, I'm just going to hold V to get a vertex snap and pop it up here to my gyroscope. And then I'm just going to come in here and fine tune it. No big deal. There's where I want to be focused. right at that leading edge there. Okay. Now, this could be enough. All right. We can see here exactly 39.819. We could type that right into our lens shader here if we really wanted to. 39.82, whatever. All right. And that's all fine and good, except if we want to start adjusting this and experimenting around with different places, then we have to keep going back and forth and back and forth. And if we're doing an animation and we're following a focus or we're doing a rack focus, we're going to have to really be careful about how we're putting this number in and keying it and things like that. So what I want to do is just create a direct correlation between this and my bokeh plane here. Okay, and we're going to do this with the connection editor. All right, so one little gotcha here is that if I select, the connection editor will load up whatever is selected. So if we do window, general editors, connection editor, I launch that and I look here, I can scroll as much as I want, and I'm actually never going to find this distance attribute. And the reason is because that I've actually selected, by clicking this, I'm selecting the transform node up here, all right, not the shape node, which is what I really want. So you can do this two ways. You can just hit the down arrow to get to the shape node, or you can, since this will probably be open, just click the select button right here. Okay, you can see that isolates that. I'm going to hit reload left, and while it doesn't look like anything really changed here, if I scroll down to the bottom, there's that little distance node, that little distance attribute. That's what we want. Okay, now to create a connection to the lens bokeh node, we want to do the same thing. Select, and I'm going to reload right here. Okay, so you'll notice it says from and to, and what we want to do is take the value from this and send it to this, and that's easy as clicking and clicking. And now you see we've got that linked. I'm going to close out my connection editor, and if I move this and if I check my bokeh, you'll see that we have a direct correlation, right? So let me put that back where it was, and that's that. Okay, we've got this set up. So this is really the one of the best setups you can have when you're doing animations, and I think even for stills. So let's look through our camera here. Nope, panel's perspective. No, of course not. Camera 1. All right, so now before I go ahead and do a full-on render, I'm going to do one last test. Okay, I'm going to select, make sure I'm looking at my lens shader, and I'm going to go ahead and launch an IPR. I'm going to bring it over here. Okay, so we're going to use the interactive photorealistic renderer to sort of get us in the zone of what our aperture should be, what our radius should be here. So we can just take a quick look and see the difference between in focus and out of focus, right? So here we are just slightly out of focus, right? And if I turn this off, right, you can see that background sharpens up a little bit. So we're just getting a slight amount of softening. I'm going to start rolling this up, and I'm just going to kind of walk it up slowly until it feels about right to me. Now here we are. We're starting to lose some of that visually noisy background here, and I'm just going to bump it up to probably push it a little bit beyond, just for the sake of showing this in the video. So there we are. We can see, and actually, hopefully the compression from the video will catch this, but there's a little bit of noise in here, so that samples is going to have to come up. But here you can see already the difference that we're gonna see from this, right? Whether it's in focus or not. So you can just see how this already is lifting off the background just by softening that background up a bit more and giving us a place for us to really look at it. All right, so I zero in with it on there. Bias is something that pushes some of the values to the outer edges of your circle of confusion. It's just one of those things you have to play with. Blade count, we probably won't really see an effect here because we don't have any hot specular pings coming off of things. So I think all in all, I'm going to call this good. So I'm going to stop my IPR, and I'm just going to hit render. And probably what's going to happen is I'm going to pause this video and then we'll take a look at the before and after. So here we are. It's all rendered and complete. You'll notice it took about 3 minutes and 40 seconds on my fairly old tower while recording a screen capture. So in comparison, the previous render took about 1:30. So it's definitely much longer, but the visual quality of it, I think, is going to be worth it in a lot of cases, right? And certainly, maybe it doesn't need to be as deep, as a depth of field as we've created here, but you can really see the difference right here. Kind of visually confusing, not really sure where to look. But here it's very clear that we should be kind of focusing in on here. And so, as a photographer, I really think that depth of field is invaluable in terms of image composition and use in storytelling. So I do find it exceptionally useful in the work that I do in 3D as well. So I hope this helps you set it up and see the difference. I think I did a better quality rendering here. There's a before and an after, right? So, so I hope this was a help and for you setting it up, and good luck with it all in the future. All right, till next time.
Shut up and sit down.